Hey everybody, so this is going to be a video on limiting reactants. So limiting reactants, the basic concept is if you don't have all the ingredients that you need, then you're only going to make as much as your least ingredient will allow. So for example, let's say you find a cookie recipe and it requires 2 large cups of flour, so 2 cups of flour, and 2 large eggs, right? And you start digging through your pantry and you find your 2 cups of flour. Awesome, you have enough flour, but you start looking in your fridge and unfortunately you only have 1 large egg. So some people would say, oh, you can't make any cookies because you don't have enough ingredients. But if you really needed to make cookies, one way that you could use all of these ingredients is to say, hey, if I only have half the eggs that I have, then I can only make half the cookies. Right. And so the basic concept behind limiting reactants is that, hey, if you require some amount of chemical, well, you can only make as much as the chemical that you have the least of. Right. And so, for example, let's say we had this reaction here. We have 2 hydrogens plus oxygen giving us 2 waters. So, in order to solve these limiting reactant problems, first, right, if you want to see how much of a product you'll make, just convert both quantities to your product. So I'm going to convert hydrogen over to water and then oxygen over to water. Okay. So 1.5 grams of hydrogen, 3 grams of oxygen. So 1.5 grams of hydrogen, I'm going to first convert to moles. That's 2 grams per mole. Then I'm going to convert over to moles of hydrogen. So it's a 2-to-2 ratio there. So 2 moles of hydrogen on the bottom, 2 moles of water up top. And then finally convert back to grams of water. So 1 mole of water on the bottom, 18.02 grams on the top for water. So 1.5 grams of hydrogen would get me 13.5 grams of water. If I did compare that to my oxygen, I do have more grams of oxygen, but we always got to be careful and convert over to our product. 3 grams of oxygen times 1 mole for every 32 grams, oxygen is heavier, times 2 moles of water for every 1 mole of oxygen, it's a 1-to-2 ratio, and then times 18.02 grams for every mole of water. That gets us 3.38 grams of water. So clearly, right, you have plenty of hydrogen because you could make lots of water with that. So in this reaction, what limits the amount of water that you can make is the oxygen. So in this case, you can only make 3.38 grams of water. And so the limiting reactant is oxygen, and you can only make 3.38 grams of water. Right. So if we look at the next example, right, 5 grams of hydrogen, 20 grams of oxygen. So, right, always start with your given. So 5.0 grams of hydrogen times, right, so first we need to convert to moles. So for every 2 grams of hydrogen, we have 1 mole of hydrogen. And that number comes from the atomic weight, right? Then we're going to multiply by the reaction ratio. So it's a 2-to-2 ratio. So 2 moles of hydrogen get us 2 moles of water. And then finally, we'll multiply that by 1 mole of water for every 18 grams of water. Okay. So if we multiply all of that out, 5 times 1 over 2, that's 2.5, times 2 over 2, that's 2.5 again, times 18.01 over 1, that'll be roughly 45 grams grams of water. If we compare that to how much oxygen, so 20 grams of oxygen, again, same kind of setup. For every mole of oxygen, there's 32 grams of oxygen, times 2 moles of water created for every 1 mole of oxygen used. That's a 1 to 2 ratio, looking at the reaction ratio. And finally, 18.01 grams for every mole of water. So that'll be roughly, and so if we multiply this out, 20 divided by 32, that would be in the ballpark of 0.62. Times 2 over 1, that'll be 1.24 or 1.25 about. Or so. You can do the exact math. I'll actually pull out my calculator. So here that. So 20 divided by 32 times 2 times 18.01. That'll be roughly 22.5 grams of water. And so you can tell, all right, you're making less water with oxygen, therefore the limiting reactant is oxygen, and you can only make 22.5 grams of water. Okay. Answers will be up on the OneNote. Take care, everybody.